For 2.2, still slope and rate of change. But this time we're gonna consider algebraically. That means we're gonna do some math work. Okay. What I said, get your hand dirty. get your hand moving by doing more math. So 3 steps method to find the derivative. I will not focus too much on this, but just I will go slowly and make sure you understand how to put pieces together using the previous knowledge to derive the derivative formula for the given function. That's pretty much the big picture of 2.3. So let's recall what we did in 2.2. The slope of the function at the particular point is the same as slope of the tangent line at that point, and also called the instantaneous rate of change. And we call that derivative of the function with the notation f prime. And the f prime is the different quotient with the limit, taking the limit as h approaches 0. Okay. The 3 steps method for finding derivative. We are talking about the limit definition of the derivative, which is f prime of x equals the limit of the difference quotient x plus h minus f of x divided by h as h approaches 0. This is called the limit definition of f prime, because we use the limit. We did some limit problems in section 2.1. So now we're going to put pieces together to come up with the derivative of the function. But it's kind of still in a tedious way. But just, be patient and hang in there. The function that we have given to be f of x equals x squared plus 3x. What are the 3 steps? Step number 1, we are going to form different quotient. I'm going to follow step by step, okay? Step 1, I'm going to put the note on the left here. Number 1, different quotient. That means I'm going to form the f of x plus h minus f of x divided by h. The function is given as f of x equals x squared plus 3x. That means I already have this term. This term is just exactly the same as what provided. But how do I find f of x plus h? On the side notes, I'm going to put along here. So if I am going to find f of x plus h, my input is x. I'm going to do the input squared plus 3 times input. Okay. Input for the f of x plus h is x plus h. So I'm going to do the quantity x plus h square, my h, and then plus 3 multiplied by x plus h. So that's a setup to find the function that we're going to use in the different quotient. Now I'm going to go with another color here. So what we're going to do, I will work on the prep on the side note here, and then bring it into the main area after I get everything done. So x plus h squared is x plus h multiplied by x plus h. A lot of algebra going on. Do not misuse it, okay? Or do not come up with your own rule, okay? If you are not sure, you can ask me, or you can look it up, or you can look at the tutorial video or the contents in the chapter 1, the earlier of chapter 1. So for this, we have x plus h, and then 3 times x and 3 times h to be 3x plus 3h. Simplify more. When you expand this, recall like first times first, you get x squared. Outer times outer, you get x times h. Inner times inner, you get another x times h. Last times last is h squared added by 3x plus 3h. And this technique if you recall, it's called FOIL technique. FOIL. Okay, the FOIL, the first time first, outer times outer, inner times inner, and last times last. And after that, you're gonna clean up or simplify as much as you can. For this problem, you do not have anything that you can see as light terms. Okay, because you have x and h everywhere except these two that you have double of the same term. So the function of x plus h simplified to be x squared plus 2 times xh plus h squared plus 3x plus 3h. Okay, from the side notes here, we're gonna bring it into the problem. Bring it in here. After you form the different quotient, I'm gonna go the next step. The next step is the step that you're gonna replace term by term. So it's gonna be x squared plus 2xh plus h squared plus 3x plus 3h. Okay, and then subtracted by original function. So I'm gonna erase this a little bit to get the cleaner look of this, which is x squared plus 3x all divided by h. Okay, step 1 is done. Check. Step 2, we're gonna simplify. So step number 2, we simplify. How do we simplify? We see the common terms or the light terms. X squared minus x squared gone. 3x minus 3x gone. Now we get 2 times xh plus h squared plus 3h and then all divided by h as a simplify of the different quotient. Actually, not the most simplified yet. What you can do, you see the common factor h here. Okay, I factor the h out of each term. So I have h multiplied by 2 times x plus h plus 3 all divided by h. And now I can see something that I can simplify further because I had the factor of the h on the top and h on the bottom. I can reduce them. So when I reduce, the most simplified of the different quotient that I have is the 2x plus h and then plus 3. I'm going to move further down here. Okay, get more room. So far, my different quotient is in the form of 2x plus h plus 3, which originally f of x plus h minus f of x divided by h. I did step 1 and step 2, okay? And step 3, we're gonna take the limit of the simplified form from the second step. So number 3, step 3, we take the limit as h approaches 0 of the different quotient, which for our case, the simplified form is 2x plus h plus 3. Okay. If you recall to find the limit where the function is the polynomial function, you can treat it the same way as you find the function value. But keep in mind, this one, you take the limit as h approaches 0. Wherever you see h, you're going to replace it with 0. Nothing to do with the x, leave it the way it is. So what we have is 2 times x, which is nothing to do with the h. The one that we can work on is the h one. So 0 here and then plus 3. So the answer is 2x plus 3. And this expression 2x plus 3 is the derivative of the function f of x, where f of x is x squared plus 3x. So we call this is the derivative of the f of x equals x squared plus 3x. But this is the hard way to do it. Okay. Just want to show you, like, do you know the slope? You can write the slope in different form, which is called the different quotient. And then you can take the limit of the different quotient, just give you the derivative and the continuation part of it. So instead of using the notation x, you replace x with the a. You see that the particular x equals a, then you get the particular slope at that point. So that means you can find the slope of the tangent line at the point x equals a. And then note here, if the limit fails to exist, or you cannot find the limit, this case the function f is called not differentiable when no limit, no derivative. Now, for the situation that the non-differentiable function might occur, okay, if the function f of x is not differentiable at the point x equals a, it could be one of these following. The function is discontinuous at x equals a. Discontinuous means not continuous, or the graph not connected. In the case that not connected would be case one here. I mean the first graph here, like, because x cannot be 0. So then the graph is separated at x equals 0. The second one, the graph has a sharp corner. That means the graph changed suddenly. Okay. If you look, the left part of the graph is rising, and then over at that point, over to the right hand side, the graph start to fall suddenly. Okay, so that's the case number 2. And then the case number 3, the tangent line at the point A is vertical. The graph looked all smooth, but what happened? If you look at the particular point here, at the point x equals 0, the slope, the m, is undefined, or is infinity basically, or you have the vertical slope. Okay, so this case, at x equals 0, fx equals the cube root of x is not differentiable. DIFF and apostrophe, the BLE, is the short term for differentiable. Okay, so 3 different cases that you can use to determine whether the function is differentiable or not differentiable. Now, the connection of the continuity or the continuous function and the limit is when you have the function value equals the left-sided limit equals the right-side limit. Or the other way, you have the graph all smooth, no vertical slope or vertical tangent line. So every single point you can find the value, you can find the two-sided limit. So that means we can say the function is continuous at x equals a.